showing plane diagram, you must have enough imagination. Cylinder, the moment I say cylinder, I'm showing only the plane diagram. What will happen to, say, like now the heat will flow from left to right part. Agree? The heat will flow from left to right part as the heat flows. So this gas will get heated up. So here volume will change, pressure will also change. So finally, what do we expect? So finally, same size cylinder. Okay, no? So let me keep it. So this will be the final. Final, we don't know the pressure, let it be P, and the temperature be T. Are you seeing different length? Let this length be x2 and let this length be x1. Diatomic, this is monatomic. As the piston is conducting, final pressure must be same. Why final pressure should be same? Because net force should be 0. Here it will exert a force PA and PA. Since conducting, temperature must be same. I agree this. Okay, let's get into the thing, that one. Okay, now in the left part, this is the final situation. This is the initial. Okay, left part. In the left part, shall we apply number of moles should be considered? So P naught AL by R into 3T naught should be equal to pressure PA, volume of gas in the left part is AX1 RT. So A get cancels, R get cancels. So P naught L 3T naught should be equal to Px1 by T. Equation 1, agreed. In the right part, what is this? What I'm writing? Amount of gas will not change. No, only the heat will flow from one chamber to. Don't think that gas will flow. How piston will allow the gas to flow? Only heat will flow. No, and since as the heat flows, here the temperature of this gas will increase, the pressure will increase, and because of that, what will happen? So what we can say that the piston will undergo displacement. We don't know altogether the length of the each part. Let it be x1, x2. If you solve, if you get equal, okay, no problem. But you should assume to be different. A number of moles in the right part should remain same. So based on that, in the right part, in P naught AL RT naught should be equal to P A X2 RT. Now your task one best questions are why pressure should be same. Finally, equilibrium is achieved. Net force should be 0 on the piston. So pressure should be same. Go back to the fluid statics. It's a fluid. This gas is a fluid. The pressure into area will be the force. Pressure into area will be the force. So this will be P naught L. Okay, how many unknowns are there? P, T, X1, X2, 4 unknowns are there. So what to do now? We'll go for int G idea. Okay, initial int G should be equal to final int G. Let me get into initial int G equal to final int G. What is initial int G? Monoatomic gas, number of moles. 3 shall I write directly or N1, F1, this should be equal to N1 F1 RT by 2. Now why final temperature? Because final temperature in both the parts will be equal. So what is T is equal to No. Number of moles 3, degrees of freedom 3, monatomic gas temperature 3 T naught. Number of moles 5, degree of freedom 5, temperature T naught. 3 into 27, 27 plus 52. The similarly 25 plus 9, 34. Okay, this is the thing. Okay, somehow I know temperature. What is the biggest problem? We don't know P x1, x2, no? So I got one equation. I'll call this as equation 1, 2, and 3. How many unknowns are there? P, T, x1, x2. We need one more equation. Anybody?
x1 plus x2 is equals to 12.
That's all. The overall volume of the gas will remain same, no? X1 plus x2 is equal to 12. Look at the diagram, that one. So what is x1 from this equation? P naught L T by 3 T naught P plus x2 should be P naught L T by T naught P should be equal to 2L. So we know value of T, substituting that we'll get expression for pressure. Okay, T by T naught value will substitute here. So L gets eliminated. So expression for this will be P naught to P. So this should be equal to 4 P naught T by, or this should be only 2. No, T by T naught, we have 52 by 34. I'll substitute here. So 2 P naught by 3, 52 by 34. Anybody value P? (52 by 51). So what happened? The pressure in each part has increased. I think I'm showing complete. You look at here. Now we can calculate x1, x2. Yes, here. Now substitute the value of P here. You'll get x1 and x2. Now let's come for this one. What happened? The RMS speed of molecule decreased, of monatomic gas molecule. Reason temperature decrease. Diatomic gas molecule. What happened? Its RMS speed has increased, no? Because 52 by T naught is greater than T naught. So temperature in the right part increases, temperature in the left part increases. What happened to pressure in both the parts? Pressure in both the parts increased. You see, P. Pressure in both the parts got increased. So there's also one equation, no? 4. Substituting 1, 2, 3, and 4, we'll get the expression for P. Then substitute that P value in x1, x2, we'll get the x1. Anybody x1?
L by 2, sir.
3L by 2, sir. Sorry, sir, L by 2, sir.
x2 is L by 2.
X1 is L by 2, sir.
3L by
X2 is 3L by 2.
3L by 2. Okay, see, these are the ways. I think in chemistry, the approach, little bit, you are bothered about gas. I'm bothered about some other things here. What are some of the things? Piston, volume, force exerted by the gas. This is what the highest priority is, what I'm going to take here. No, but you should never leave the things. What is that? The RMS speed of molecules, as temperature changes, RMS speed of molecules will change. Overall energy of the gas will remain same because it's insulated, no? So no question of heat exchange from the cylinder to the atmosphere outside. So what all heat exchange occurs between the gases in each part. Therefore, energy is conserved. So what is your approach now? Number of moles you have to check. As it is insulated cylinder, no escape of it, so overall intensity remains constant. So these are ideas. Conservation of intensity. This is the one thing. Next thing, number of moles in each part remains same. Pretty sure. Then some geometry. Overall volume of gas in a cylinder remains same. Rest all solve. Okay, now I think almost we are at a certain very good place now. Let me introduce the idea of pressure.
Sir,
Why
here we did not use UI equals to UF, no sir.
that only I use no? What is this? Are you not seeing this?
Okay, sir. I thought you directly wrote T formula, sir.
No. This is a thing. No?
Okay, sir. Okay, sir.